In this video, you will learn how to get started with the PIC24FGP and GU205 family of extreme low power microcontrollers using the PIC24FJ64GU205 Curiosity Nano development board and MPLAB code configurator. The PIC24FGP and GU205 microcontroller family are extreme low power MCUs ideal for cost-sensitive applications. The GU and GP family features ultra-low power operations with sleep current down to few hundreds of nanoamperes while retaining the complete RAM content, making it perfect for battery-powered portable applications. These devices offer a rich feature set that includes full-speed USB 2.0 capable of dual role as USB host and USB device, integrated analog ADC, comparators, and many core-independent peripherals to reduce your BOM cost. Offering features like code guard flash protection and flash configurable as OTP, this family enables implementing code protections and immutable secure boot. The AEC-Q 100 Grade 1 qualified family can operate up to 125 degrees C and feature a range of hardware safety features for robust operation in extreme environments. You can get started prototyping your design using the Curiosity Nano board featuring the PIC24FJ64GU205. Let us look at the resources available on the board. The board contains a PIC kit onboard Nano debugger for programming and debugging the PIC24F MCU. It supports virtual COM port and logic analyzer. There is a target micro USB connector for developing USB device applications using the PIC24F's USB peripheral. There is a user switch for the user input and an LED for indication. You can also access all the I/O pins of the MCU as they are connected to the two rows of 24-pin headers. Users can extend the capabilities of the PIC24FJ64GU205 Curiosity Nano board using the Curiosity Nano base for clickboards. This serves as a hardware extension platform to ease connecting extension boards like the Microbus Click modules and Explained Pro extension boards. To get started developing an application on this board, you will need to install MPLAB XIDE, XC16 compiler, and MPLAB code configurator. If you are new to the MPLAB ecosystem, watch our videos that are linked in the description below. You can find resources like example codes, user guides, development board guides, schematics, and other documentation on the PIC24FJ64GU205 device product page and the Curiosity development board page. Now, let's demonstrate how to get started with a basic USB application using the PIC24FJ64GU205 that implements the USB communications device class to emulate a serial port. Open MPLAB XIDE and plug in your Curiosity Nano board to the debug USB port. The IDE will recognize the development board and display the kit welcome page. This has quick links to the resources for the PIC24FJ64GU205 family and the Curiosity Nano development board. Now, create a new project. Enter the target device and select the PKOB Nano Debug tool. Select the XC16 compiler. Enter a project name and launch MCC. Go to the Device Resources tab and add the USB Device Lite module. Select the class as CDC and we will go with the default configuration. Now, select the Generate Example Code option. To set up the system clock for the USB peripheral, we enable the PLL, which gives a CPU clock of 32 MHz and USB clock of 48 MHz. Make sure to verify that the USB interrupt is enabled. Using the Pin Manager grid view, select the debug PGC and PGD signal on pins 21 and 22. Now, generate the code. We can look in the project view and see all the MCC generated code and the USB library. In the main function, we can find a system initialize function that sets up the MCU and the USB peripheral. We can insert our USB application in the empty while loop in the main function. There is a simple demo in the USB folder generated by MCC. The demo code takes a character from the receive buffer when a new character is available and sends it back to the host after incrementing it. Copy this function and add it in the main while loop. Now, build and program the MCU. After successful programming, unplug the MCU from the debug port and connect it to the target port. To see the demo, open a serial terminal program and configure it as needed. As we start typing using the on-screen keyboard, you can see for every character sent to the MCU, the returned character is the next character in the ASCII table. We hope that you have found this demonstration helpful. To learn more about the PIC24FJ64GU205 Curiosity Nano development board and the PIC24FJ64GU205 low-power MCU family, visit microchip.com/PIC24FJ64GU205 and microchip.com/PIC24FJ64GU205-C Nano. Thanks for watching.